Well, welcome back, guys. Hope you had a spectacular weekend. That you were able to get out at some point and enjoy some nice weather and some sunlight. Um, and just hope that you guys are continuing to do well as we progress here. Um, anyway, so you guys may have noticed have my hair up here today. So I just figured, really, I just kind of wanted to get my hair off my forehead, kind of out of my way. So I don't know if I'll leave it like this. As you can see, the length on the top and it getting poofy on the sides here. So it's getting quite interesting. I hope you guys enjoyed, those of you who tuned in and watched. Me complete the Bean Boozle challenge on Friday. Hope you guys enjoyed that. Remember, if you are one of the winners of the week for the Math Olympics, then you will get to choose a teacher and a challenge for them to complete at the following week. So just keep that in mind as we progress along, that you and your classmates might be one of the winners if you guys get the highest completion percentage or just the highest average on an event. So keep at it. Keep working hard on that, guys. Today's Mr. Sorrell's trivia question deals with lucky numbers and favorite numbers. So in 6th grade, for me, was kind of the year that I solidified what my favorite number of all time is. And the reason I say solidify is because this was the year that I decided that basically the number that I was going to have on all of my sports jerseys, number that I put in my professional sports signature, and just the number that I favored the most. So simply my question today is, what do you think my favorite number, and it's still true to this day, what my favorite number of all time is? I'll give you a hint, since it did go on the back of jerseys. It was in between 0 and 99. So, but yeah, it's still my favorite number today. I may have mentioned it before to some of you, and yeah, just curious what you guys think that may be. And I want to know from you guys maybe what your favorite number is, or maybe just lucky number that you have, and why that might be your favorite or lucky number. Okay? I want you guys to go ahead and do that now. All right, guys. So my favorite number of all time is the number 22. I don't have a particular reason for that other than I've always liked the number 2, and I thought having it twice on there, because it's two twos, making it 22 would just be like the ultimate twos there. So yeah, I don't really have a particular great reason. I mean, 2 goes into all even numbers. It splits it in half. Multiplying by 2 is nice and convenient. I do like things in pairs. I like having parity and evenness. So I don't know if that's why I tend towards the number 22, but that's part of the reasoning behind it. So moving on to today, we're gonna talk about area of trapezoids. So far we've talked about the area of parallelograms, rhombi, rectangles, squares, and triangles. Well, now today we're going to look at the area of trapezoids. Okay? And we're going to break this down. Now, this formula may seem a little daunting at first, but we'll work through it and break it down so that you guys have it. All right? So we have a pasture that's in the shape of a trapezoid. How do we know it's in the shape of a trapezoid? Well, a trapezoid is extremely unique in that it has exactly, no more, no less, but exactly one set of parallel lines. Okay, recall that parallel lines are lines that will continue on in the same direction and will never touch, whether they go this way, or completely, completely horizontal. As long as they never touch, yeah, they're parallel. And all trapezoids have exactly one pair of parallel lines, meaning a pair of parallel lines would be two lines that are parallel. So if you notice down in this trapezoid, we know it's a trapezoid because this line is parallel to this line. That's a bad arrow there. There we go. Better. So we know that those two lines are parallel. That makes it a trapezoid. Okay? Only a trapezoid. None of the other lines are parallel either. And this next sentence says, so the trapezoid is a quadrilateral that has only one pair of opposite sides that are parallel. That's exactly what we talked about. We want to know what the area of this pasture, of this trapezoid, is going to be. Now, here's where it may seem a little complicated. I want you to write down this exact formula that we are going to use to find the area of trapezoids. Okay? This is highly, highly important because you'll need to memorize it next year in the future. Okay? Area of a trapezoid is A equals half multiplied, put a little multiply there, by, in parentheses, base 1 plus base 2 multiplied by the height. Now, if you notice, okay, it's not too different than our formula kind of for area of a triangle or even area of a parallelogram. The area of the triangle is just half multiplied by base multiplied by height. Well, a little bit different now in that we are actually having to add two bases together before we multiply it by the half and by the height. So breaking this down, B1 and B2, I'm going to write it over here on the left. B1 stands for base. This is something else to write down, so you should write down formula for area of a trapezoid. This is base 1. B2 is base 2. Well, where do base 1 and base 2 come into play? Okay, base 1 and base 2 are always, okay, can't emphasize this anymore, any greater, are always the opposite parallel sides. Always. Okay, they can be interchangeable however you want them to be, but they're always going to be the opposite parallel sides. I like saying that the longer base is just base 1, just to keep it nice and simple. So the base of the trapezoid, so this is the base of the trapezoid, and we're going to say this is base 1. So that longer base we'll always call B1. And the shorter base, in this case the top base, we will call B2. Okay? So base 1 and base 2. The height is just like what we've talked about before. So H is standing in place for the height. I'm going to do my best here to write the word height. The height, just like in a triangle, just like in a parallelogram, is that distance from the top, or base 2, all the way down to base 1. That's going to form, look, there's that right angle again, that perpendicular angle, forms that right angle, and it's got that X marks the spot. I'm telling you, if you can remember the right angle and the X marks the spot, it's going to help you so much in finding the area of every single one of these. Okay, this line, this perpendicular line from base 2 to base 1, connects the bases, and it's pointing to which bases you need to use to figure out area of a trapezoid. Okay, And as well, this line represents that height. Okay, so we have base 1, base 2, and our height. Now we just got to figure out what those numbers that we need to use are and substitute them in. So let's go ahead and do that. I would like you guys, as I'm writing this down, to walk with me and write this down as well. So we have A equals, I'm going to put in half, multiplied, and in parentheses, base 1. Now base 1 is the length of the entire base. So notice that this 4 yards is only the distance from this point to where the right angle is. So we are not going to use this number. Instead, we need the entire distance, which is 18 yards. So we're going to put in 18 for base 1 plus base 2, which is the entire base up there, and that was 10. And then multiplied by our height, which is 12. Is 12. Oh, funky 12 there. And now we can go ahead and use order of operations to solve this out. So we have A equals, and we're not going to do it all in one step, half multiplied. Now, to follow order of operations, we're going to have to do what's inside the groupings, which is parentheses first. So 18 plus 10 is 28. And when we do that, our parentheses can go away. We have 1/2 multiplied by 28 multiplied by 12. And then we're going to put A equals. Now, since there's no more groupings and all of our operations pretty much are the same, we can go ahead and use our calculator and type this in. I'm going to enlarge my screen so you see what I type in here. Okay, so we have 1 ABC, so we're typing in the fraction, so 1 ABC 2 multiplied by 28, and then multiplied by our height 12. So you can type all this into your calculator. You can hit enter, and you're going to get 168. And that's going to be the area of our trapezoid in our pasture. Now recall, since we're dealing with area, our units are always going to be, squared. So, since our units here are all yards, our units for the area of 168 is going to be yards and squared. So area of this trapezoid is 168 yards square. If you haven't yet already, please write down this formula right now, because you will need this formula for everything you do. And you can write this little key down as well so that you have it. Okay? Let's move on to the next question. So for this one, we have our trapezoid, but it's tilted a little bit differently. Remember, as I said before, we're looking for that right angle, and there it is right there. So we need our formula for area of a trapezoid. Okay? I'm going to go ahead and take a moment and write that down. I want you guys to try and write that down as well. So recall here, our formula for area of a trapezoid is going to be half multiplied by, in parentheses, base 1 plus base 2, close parentheses, multiplied by height. Okay, but where are we going to find out which one of these numbers represents what? So recall, our base 1 and our base 2 are always the opposite parallel lines. Well, what lines are parallel here? Well, if we look at this one here, this bottom line here and this bottom line here, well, one's straight and the other's slanted. These can't be parallel, because if this line were to continue down all the way and this line were to continue on, they'd eventually run into each other. So this automatically eliminates our base. Well, there's only 2 numbers left, and these lines are parallel. They'll never touch each other. So those 2 must be our base 1 and our base 2. So we're going to go ahead and type that in, or write that down. Okay, guys. Okay, guys. Once you've written that down, head on to part two.